Alright, so today we're going to learn about vertical shifts. And so basically we're going to have two things. We're going to have A, which is the amplitude of sine of B of x, which B of x is the horizontal compression or stretching that has an impact on the period. But more importantly, we're going to do this plus or minus k value thing on the back end of sine and cosine. And so basically k, if k is greater than 0, which is positive, it shifts the graph up. If k is less than 0, which is negative, then it shifts the graph down. And that's what it says here. Okay? And that's basically it. Alright? So we're going to get to a point where, like we're going to graph up or down, and it may not cross the x-axis. So part of the transformation is shifting the graph up or down. Alright? So let's take a little bit of a deep dive and do example 1. Can I move on to the next slide? Yeah. Okay. So let's try to graph this one. Now, the one thing I should point out, and this was on your homework for the last section, but it was, I don't know, I said it like one time and I didn't really emphasize it. When we graph stuff, we don't, because they're sinusogenous, they go on forever to the left or right. They're circular functions, so the pattern repeats over and over and over. So usually they'll give you the boundaries for x of what you're going to graph. So this right here, when they define it as this, or sometimes you'll see it written like this, where they'll say negative, this is called interval notation. And then like your homework problem, they said 2p, negative 2p to 2p. And that's just telling you how much of it you need to graph. That's all they want to see. Otherwise, you'd go on forever, right? So that's what they're telling us. So when we go to graph this thing, we're only going to go from negative pi over 2 to pi over 2. All right? So we want to graph this. So the first thing I need to do is I need to, and this is an interesting thing, they write it a little different. They say y k minus capital A sine of bx. I don't know why the textbook does it that way. It's really confusing. I've never seen it written that way before, ever, and I've been teaching math almost 20 years. Well, actually, probably longer than that. No, 20 years exactly. So, but we'll just roll with it, I guess. So, we need to identify something. So, we know that k is equal to positive 2. We know that a is equal to negative 3. And we know that b equals 4. Okay? So now if I'm going to sketch this graph, let me put a little graphy graph in here. Now I'll make it a little bigger. I know that my amplitude is going to go from 3 to 3. So I like to sketch out like a little line or whatever. So normally I just draw dotted lines, but this software doesn't let me draw dotted lines. And so what I'm going for is I'm going to go from 3 to 3. But remember, there's this little I got to shift it up 2. So imagine that this is 3, and this is -3 on the y-axis, because that's how it would normally go, right? But now I'm going to shift the whole thing up 2. So this is what you kind of have to imagine in your head. I'm going to go up. Yeah, I got to click it just right. Okay. I'm going to take this whole, whoops, I had it. I'm going to go up 1, 2. And we'll just pretend that that is 2 spots. So now my boundary is going to be, what would this number be if I went up 2? 5. And what would this number be? -1. Okay? And then you kind of got to imagine somewhere in here is the middle, which is actually going to occur at, actually that's not the right spot for that. This is -1. So this would be like 1, and then it would shift up 2. So normally the graph of sine starts here, but it's now going to start up here at 2. So this will be like my, I don't want to say line of symmetry, but it'll be the center of the graph. Okay? And then, so now I kind of have the position of where the graph is going to go, but now I need to know the period. So remember that the period P is equal to 2 pi over B. But we said that B was 4, so it's going to be 2 pi over 4, which reduces down to pi over 2. So I'm just going to randomly put a dot here, and I'm going to call this pi over 2. And the same distance over here, I'm going to say -pi over 2. All right, so now here's the interesting thing. If this was sine, right, it would start here and kind of go up like this and come back down and then be back here by pi over 2, right? So it would go up like this, come down through here, and then finish right here. But A is -3. So what does the negative part do? It's going to flip it. So instead of going up and down, and also it's going to cross through the middle here. So I'm just going to put a little dot here because that's where it's going to cross. So I'm going to do my best, and instead of going up, I'm going to come down. And so what is, and you got to kind of sketch it. It's got to come down, and then it's got to complete one whole cycle. So let me think here. The halfway mark, it's got to come all the way down here, and it's got to be right here at the halfway mark, and then come all the way back up and here. You see how I did that? So the halfway mark is about right here. So what I'm going to do, I'm going to come down, then I'm going to do the same thing on the other side. I'm going to go up, and that's kind of what it should look like. And then what I'm going to do is I'm going to get rid of this, and that's kind of what it should look like. Now, how do I double check to make sure I did my work right? Yeah, I'm just going to graph it. That's it. I'm just going to graph it. So that was y equals 2 minus 3 sine of 4x. And I'm just gonna, to make my life a little easier, I'm gonna put the step as pi over 4, because that halfway mark is 1/2 of pi over 2, so 1/2 of 1/2 is 4. And then I'm going to go from pi, well, negative pi divided by 2 to pi divided by 2. And then for my, yeah, we'll just leave it like that. Now this graph looks much better than mine, but it's right. Let's see how close we were. Did I close that out? I guess I did. That looks about right, right? Comes down to -1. This comes down to -1. Yeah. See how I did that? So what I want you to do when you go to do your homework is we're just going to kind of guess what, you just kind of sketch it real quick, and then to double check, on when you do